Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Brenda Frye, an Associate Professor of Astronomy at the University of Arizona. Welcome, Brenda.
Thank you. Yes.
When I invited you to be on the show, I was thinking about some work you'd done with the James Webb Space Telescope, but then you replied that you and your students just found the most distant Type 1a supernova, and you'd like to talk about that. Is there something different about a Type 1a supernova from other types of supernovae?
Yes, definitely. So the Type 1a supernova is what we call the detonation of a white dwarf. So it occurs in binary star systems. In fact, we only have, one sun in our solar system, but the majority of stars come in binaries. So in this case, it would be two stars that orbit each other, and one of those stars will evolve and age more quickly than the other once it stops fusing hydrogen into helium, which is what a star does in its adult stage of life, so to speak. It will retire to become what's called a white dwarf. And it can then have gas from its other star accrete onto that star, push it above a certain mass limit, and it will explode as a Type 1a or white dwarf supernova. The other type then is Type 2, and Type 2 supernovae come from the ultra-massive stars much more massive than our own sun, which then explode and become what we call the Type 2 variety.
The importance of finding a distant supernova is more than just going after a Guinness Book of Records sort of thing. Could you explain why it matters?
The supernova that we discovered is especially important because it is gravitationally lensed into three different images of the same supernova at different times during its explosion.
Could you explain gravitational lensing?
Yeah, sure. Well, gravitational lensing is a phenomenon that Einstein explained to us over 100 years ago. He says that a mass bends the light around it, and the more massive the object, the stronger the effect. So we study gravitational lensing by galaxy clusters. So these are the heavyweights of astronomy, the single most massive objects, because they'll bend the light of objects in the background into brighter and larger sources than they actually are, giving us privileged views of the distant universe.
How far away is this most distant Type 1a supernova?
Well, it's what we call more than half the look-back time of the universe, or it's more than half the age of the universe. It's what we call a redshift of 2.
You involve a lot of undergraduate students in your work. A lot of faculty involve graduate students, which I know you do too. But how do you find the right undergraduate students to contribute to groundbreaking work like this?
I invite any undergraduate student to join my team. I remember one time, it was a very long time ago, it might have been a few decades ago, that I read of some announcement in a different country. There's an announcement that said anyone who wants to be on the gold medal winning women's volleyball team 4 years from now, show up. And the point was that they had to show up every single day, and that coach would turn that team into an Olympic medal winning team. So I sort of carry that story a bit with me, and I actually ask any undergraduates who want to come, they can come. But in order to get a project going, they just have to show up every day. And I do have meetings every day as opposed to the usual weekly meetings that's more typical in the department, so that undergrads can have a chance to train up and get that extra experience that they need in order to contribute to this work.
Do you do something different in the way that you choose projects to make sure that they will work for undergrads, or do you just fit the undergrads in?
What I do is I try to carve out tractable problems for an undergrad. And sometimes I will have 2 or 3 undergrads working on the same problem as well, so that together they can have a support group and be able, and once they can contribute a small problem, then we carve out another problem and another one until we together build up a result.
Thanks for talking with us, Brenda.
Absolutely, yeah.
And good luck to you and your students. Our guest today has been Brenda Frye, an astronomer whose team has recently discovered the most distant supernova known. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.